Thank you, Amanda. Hi, Jules. Long time no see. So thank you again. I think the next topic of the next session is going to be on augmented intelligence and use in general dermatology. So I think all of you had the opportunity to kind of go through these amazing talks. Like, I was blown away with all the work you guys are doing. This is fantastic work. I personally know some of you working on those projects, and this is a great team, and I'm really honored to kind of moderate this session. So on the top left is Dr. Art Papier. He is he's the CEO of Visual DX, and I hope you had your talk was like really amazing. I'm not going to be. I'm just going to be talking about and introducing you all. I might screw up your affiliations, so I'm going to just go by names. Dr. Jutika Thakur. Did I say it right? Okay, thank you. Susan. And I don't know. This suddenly everything vanished in front of me. And Dr. Borve, Dr. Liu.
Alex, just call me Alex.
And me. Yeah, I'm the sixth person on this. I'm still waiting for Christian to come and join us. Hopefully, we get to ask some of the questions to him too. As I said, the way we're going to do this is I have a couple of hot topic questions, and we'll go through the moderator console and see if there are any burning questions. And if you have not answered them, I would kind of ask you those questions. With that, let's start with the first question. Augmented intelligence and triage. I think in any clinical setting, like let's say you're using in dermatology or teledermatology, especially in teledermatology, as this is the World Congress of Teledermatology. How do you guys envision that the augmented intelligence is going to help or make the triage system of these dermatology conditions better? Art, I would go with you first. How would the decision tools help us triage things? What for our audience?
Who are you asking, Dr. T?
Art?
Oh, sorry.
No worries.
It depends who the audience is. Is it, the primary care, or a front desk staff for dermatology? And so there's certainly a need where a patient contacts a dermatology office to triage a patient to be seen right away, or they can wait 3 months if there's a 3-month wait. And I think that's going to be a combination of education for the staff and machine learning tools. It's all sensitivity, specificity. The more diagnoses you handle, the more ambiguity there is. It's tougher for these systems to be really accurate. And it's really, what's the promise of your system? I think that, of course, there's this huge amount of hype around AI and machine learning right now. And there are obviously remarkable advances in the field. But when you get into hundreds of diagnoses and you're talking about triage, there's still going to be a human component. So if you're doing the triage with staff for your derm office, you need to train that staff to use that augmented intelligence appropriately. The focus of our work at Visual DX is really been thinking about the non-dermatologists and thinking about how GPs, ER doctors, how do we extend the reach of dermatology, improve skin care through augmented intelligence among non-dermatologists? I'll leave time for other people to weigh in.
Right. So yeah, Alex.
Hey, Dr. T. So it's very interesting to observe it. Look, everyone in this conference are.
Alex, do you mind bringing the mic closer to your mouth?
Yes. So everyone here in the conference are visionaries. We all know what you're doing. What is interesting in this panel that 50% are not dermatologists. That's my point.
Okay. Yeah, of course.
Let's hear
yes,
from the
you're right.
non-dermatologists.
Yeah, 50% are not. Actually, I think just 3 of us are dermatologists and the other 3 are not. Thanks for letting me know that, Alex. So, you know, if you run a clinic, an efficient clinic or an efficient ACU, one of the biggest challenges is scheduling patients. And you know, Jyotika, I think this would be a good kind of an opener for you of how the decision models can help the scheduling team or the scheduling staff, or do we need schedulers in future? That would be a great question to answer.
Yeah, I think the scheduling component actually underscores the importance of triage, right? How do we schedule these patients? And when we were thinking about triage, we found 3 main domains. The first was, you know, is it urgent or non-urgent? Is it skin cancer or not? And the probability of that. And then can we assign some of these non-urgent cases to different levels of training, specifically in academic institutions like residents or nurse practitioners? And then lastly was, you know, how do we redirect this referral to the appropriate physician, like an onco-dermatologist or a medical dermatologist interested in autoimmune and bullous diseases, for example. So once we have that input of information, scheduling becomes really easy. You know, do they need to be booked within 1 week, 1 month, 3 months? And for us, what we've decided in our model is to actually give that power to the patients to book something within that window of triage. So that's what we've really built into our digital dermatology hospital concept.
Cool. Yeah, like, you know, that was one of your highlights when I was looking through your talk. It was really, really cool. Dr. Liu, where do you think, you know, we recently, you know, it's a recent terminology. Like, did you check with Dr. Google? It's like the first thing is like, as soon as the patient arrives into my clinic, yeah, I did check with Dr. Google, right? So there's so much information, and what is right and what's wrong is one of the things which everybody struggles to, you know. So how do you think that this model of yours would incorporate ideal patient education when they use the model which you presented in your talk?
Yeah, that's a great question. So first, maybe let me separate the different kinds of models and efforts that we have going on. One is a AI model that I think we described in Nature Medicine and JAMA Network Open. And this was a study which was primarily meant to evaluate feasibility and efficacy as a standalone device. And that model is what we described in the talk. And the way that we have taken the output of that model and presented the predictions to the users in this study, and the users in the study were primary care physicians and nurse practitioners, was geared more towards the clinician. And so there was a lot more, detailed clinical pros and, how does one treat this disease and so forth. So I think it's really about information presentation to the right audience. What in your question you were asking about Dr. Google and patients using Google or other, web resources to find out more about a condition before they get to the physician, or maybe even thinking about whether they should go visit a physician. That's slightly more relevant to another aspect of our work, which involves more of how do we take output from a model, whether it's the same model or not, and how do we structure it such that lay users, non-clinicians, non-professionals can understand that information, and importantly, understand what is useful from that information, at the same time, really making the decision themselves about what to do with that information. Because what's really important, I think that's mentioned in this panel and several of the talks, is that no decision maker, AI, human, textbooks, otherwise, will ever be perfect. There needs to be an element of safety and caution in this process that really allows independent decision-making and understanding. And so what we really want to do is to augment the information they have to make better decisions.
So if you've heard me talking, I'm not saying artificial intelligence, I'm talking augmented intelligence. I think all of the panel will agree that it is more augmented intelligence than artificial intelligence. I think that's we know where we are getting that. So the reason why I asked that question is because, looking at your model, like in future, if I were the CEO of Google, which I'm not, I would use it to kind of, open it up to general public, because the accuracy is not bad. And with that in mind, that's the reason why I asked you that question. Like, if this becomes kind of a more operational for anybody, how would you help patients or a layman understand? And I think that I got your answer on that. Thank you very much. Susan, your take on the triaging. What do you think is the most important thing for augmented intelligence and triaging to happen?
Yeah, so I'm not a dermatologist or primary care physician, but we have spoken to at least 300 and identified that how primary care physicians evaluate cases is often in the bucket of, is this a lesion that I'm worried about? Is potentially cancerous, or is this a rash? And what rash is it? And then what we've seen in behavior is that they'll say things like, well, if it's a rash, it's really not likely to have serious harm for the patient over the next month. And so I'll try to treat the patient and see if they can come back if a treatment doesn't work, if it's wet, dry it, if it's dry, wet it, sort of algorithms. And so what we've found is that, and another thing is that they'll say, oh, it's a rash on the elbow. I think it's psoriasis, but I'm not quite sure what else it could be. And so how we've taken that approach is we generally help them build that differential of replicating the process that a dermatologist goes through in visual recognition, right, when they walk in the room, and then help point them toward the history that specifies the differences between those different conditions or visual features if they need to pick out if they're comedones or something like that. And so how we've really thought about it is like, how are they already behaving in practice today? And what are their algorithms that they're working on just in the back of their head from training? And then how do we support them in that process to help more patients get a better outcome faster?
Excellent. Yeah, I think I was looking at the moderator board. We still don't have any questions. So that gives me an opportunity to ask the panel the next question. Each of you can kind of take your expertise and give me this answer based on that. What do you guys think is the biggest hurdle for augmented intelligence adoption, design, and operation? So I'll start with Alex. Go ahead.
Hey, Dr. T, I love this panel. This is fantastic. But I feel that we all kind of figure out that AI and dermatology have solved the dermatology problem.
Hey, you got to keep your mic closer. I'm not able to.
Okay, hypothetically, we have solved AI and all the dermatology. Okay, hypothetically. That's what I think you should focus on this conversation. We have someone from Google who owns the internet. We have Dr. Patier, who he's got the best images in the world. And then we have someone like Susan. In a couple of months, she has 500,000 images for data set in her 20s. She's a game changer. It's not me, it's not Patier, it's not Google. All this is gonna solve. All of this is gonna be solved. But I want to see how we can move faster. And I want to see how we can make Susan as a star in the ecosystem of healthcare, because she has a drive. She's not a doctor, but she's a believer.
Yeah, I echo your sentiment. I've met Susan in the past, and I kind of echo your sentiment on that. Dr. Papier, what's your take on what do you guys think that the biggest hurdle for the adoption or the design model of augmented intelligence in dermatology?
I think the biggest impediment is the culture of medicine. Medicine doesn't like change. And so for every action is a reaction. And, we have a flawed educational paradigm in how we teach medical students, how we reward medical students and reward residents in the training. We reward them for answers. We don't reward them for the process. And so we have to move the rewards from a memory-based system of rewarding your board scores to rewarding people that can use these tools elegantly and tolerate what's going on in the exam room over time. Diagnosis is a process. And, my mentor said, a final diagnosis is a myth. Well, that's kind of hyperbolic. But what he was getting at was this idea that you don't want to have premature closure on the diagnosis. You want to handle the ambiguity of what's going on in the exam room. And all diagnoses are not created equal. I mean, we walk in the exam room from several feet away. Half the time we know the diagnosis with no history. Well, machine learning is going to do exactly that, quicker and cheaper. But then there's the other half of the diagnoses that are fraught with sand traps and error and risk and liability. And that's a lot more challenging. And so the people that think we're solving that problem tomorrow just because AI exists are, I think, a little delusional, because we don't, in any system where you don't have final knowledge, and there are a lot of diagnoses that we don't have final knowledge, we see them in our clinics and we don't know, what is this? Well, you need intelligence to help you do discovery too. So that's what makes this so wonderful. I mean, it's not something we're solving overnight, but the low-hanging fruit, everybody on this team, it's going to be a commodity. I mean, the easy stuff's going to be easy. It's the hard stuff, right? It's really the stuff where even the experts are scratching their head going, I don't know what this is.
Yeah, I completely agree. That happens to me at least twice in the week when I go and see my patients in the clinic. I completely agree with you. Susan, what's your take? What do you think is the biggest limitation or a hurdle for augmented intelligence? I would say designer-wise. I know I look at you as more as a designer of this augmented intelligence than an operational or anything like that.
Sure, I'll take it. I think there are two primary ways that are just big blockers to innovation. The first is exactly what Art said, culture of medicine. You're not going to get a doctor to start using a technology because it'll help them be more accurate, which is a little bit terrifying. You need to sell your value in some other way. So that's how we really thought, like, how do we shave time off of an encounter for them? And how do we, work toward other value props that get them really excited? And then the second thing is, interestingly, the FDA. So we've gone really deep in what's the process to have our product that addresses rashes, get approval, get a CPT code, go down this avenue that's been trodden before to tap into and support fee-for-service doctors. And we learned that based on how it works today, is so focused on the older way of diagnostics that, you know, if you have 90 diseases in your AI algorithm, you have to have 90 different submissions. And so that's just, you know, a little bit of a barrier, and we're answering a different question, right? We're answering what are the likely conditions this could be, not what's it as a diagnosis. And like everyone on this call knows that history really can make a difference in differentiating one condition from another. And so I think both of those things could, if we could change them, then we'd be, you know, rocket shipping forward.
Yeah, that's so spot on, Susan. I mean, where the FDA is thinking about diagnostic software, and in this conversation, we're talking about augmented intelligence and improving the diagnostic process, and they're very different kind of regulatory questions. And it really depends, like, what your promise is. Like, we're not trying to make a promise that we're better than the best dermatologist for 400 diseases. I mean, I think we're going to see lots of models that say, yeah, this is better for melanoma than many dermatologists, or this is better for specific diseases. But when you're talking hundreds of diseases, then I think the FDA needs to think about this as, you know, supportive and augmenting.
Well said. Well said.
And I want to chip in there on, Mr. T, can I chip in there on Art and Susan? So I totally agree with this regulation. And it's also this, you know, everybody knows what a Ferrari is. A Ferrari red car, really fast. But if we're going to sell a Volvo that's red, turbo engine, and we sell as a Volvo, it's a Volvo. But if people interpret it as a Ferrari, sure. But we're still selling a Volvo. And that is one thing that's important that we get across to these regulators, what the intended use is. That they don't interpret the intended use to save every person that do a search or do something with this AI. We know what we're doing, and we are intelligent people. We're not just moving out of a garage that we have an idea. No, we've been doing this for years. And the most important thing for us and our investors and our advisors is that we do things correctly.
Well said. Dr. Liu, what do you think is the biggest hurdle?
There's probably many steps, maybe not hurdles, but steps remaining to really getting you know, AI in use. I think part of the complexity is the human AI sort of like intersection. It's where things get really complicated. You know, if you have a data set, you want AI to do some classification problem, it can do it, no problem. You know, sometimes better than, sometimes on par, sometimes worse than humans can, but it can perform a task that you set out in very precise steps. Where it gets complicated is when you now start to say you want this to work seamlessly with the rest of the clinical workflow, or with people who want to find out certain things. And every workflow is different. Every person is looking for something different. And so how do you solve the interaction problem? How do you account for the fact that you have users from opposite ends of the spectrum? Some are over-reliant. Whatever you say, they take it at face value. Some are way under-reliant. They mistrust anything that you say. How do you encompass and take into account both kinds of users in the same tool and same presentation? I think that's one of the, you know, really big challenges remaining for us all to think about and hopefully solve.
Awesome. Awesome. Thank you. Jyotika, what do you think?
I mean, I would echo a lot of the challenges that everyone has already said, but I think the one that I'd like to underscore is dermatology it's a wide specialty. It intersects so many other specialties. There's variabilities in common diseases and presentations. And, you know, the challenge when we're building models is what is even the gold standard for the correct diagnosis. And the dermatologists on this panel definitely recognize that, that ambiguity, and how do we build that into something that is more concrete. That is the challenge. And then again, to Dr. Liu's point, is how do we make sure that there's enough data to support explainability, to support that clinical decision maker. I think that's the main challenge. And sometimes we're impeded by, and often we are, by the culture of medicine as it exists today. But I think with COVID, we are breaking down a lot of those barriers. Many physicians have become comfortable with teledermatology because they've been forced to adapt. And so I'm really optimistic and hopeful about the next few years ahead.
Yeah, I think it's well said. Alex, you had raising your hand.
Look, I had to compliment Yaka, dermatology is really important. But if you really look into who's paying for dermatology, it's the payers in the US. Sorry, it's the payers in the US who are paying for dermatology. Only 3% of insurance costs is dermatology, right? Today, we have a pandemic. And thanks to artificial intelligence, we're talking about 3,500 diseases. When you go and discover drugs, new vaccines, we're talking about billions of data points. That is where AI is, and that's where it saves lives and reduces costs. What we're talking about today, dermatology, I love dermatology. It's fantastic. But the potential of artificial intelligence, it's just too much. We don't grasp it right now, but it all comes down to the cost of the insurance companies, which is only 3% right now in dermatology.
Yeah, I think that's a very interesting point, Alex. I think we all understand that, and maybe we will include such topics in the future. But I think I completely agree with you. Like it is the insurance. Like let's look at this way. We didn't need a pandemic to make telemedicine happen, right? Like a lot of us on this panel, we were probably the first and the vocal kind of proponents of telemedicine. It's like we wanted telemedicine to happen before the COVID. And we knew what were the limitations. And the limitations were just two. One was the restriction by the CMS. The second one is the reimbursement. Once those two were lifted, everybody became a telemedicine expert. Trust me, it went up like nobody's business. I think it's the same way. We need to recognize some of the obstacles. That was the reason why I brought this up, is like, what do you think is the biggest hurdle in the adoption of, because this is next. This is what, like, I don't want another pandemic to create this AI to be adopted. So looking at the factors, which would be the biggest factors, which would act like a hurdle for augmented intelligence adoption and design. So that's the reason why I brought this up. I think the panel, as I said, I'm really humbled and honored to be moderating this panel, because I think you guys are the leaders of the future. I'm looking at you, Susan, and Dr. Lu. Yep. So with that, I'll kind of take another look at the moderator console and see if there are any more questions. Okay. So I think this is for anybody to answer. Algorithms are powered by data. What do you think of data used as a common good? I believe then that it should be standardized or on a systemic scale. That is what the ITU WHO focus group does. I think this was just a comment made. I don't think this was any kind of a question. Yeah, like, algorithms are powered by data. What do you think of data used as common good? Anybody wants to answer that question?
Certainly dermatology has variable data, especially compared to other medical imaging areas. And so, I mean, it's tricky to standardize it when it's taken on Galaxy phones and right, iPhones and Nikon cameras and old Kodachromes. But I think it's an important point, right? How do we shift this art mixed with a science field more towards science and like more definitive answers for patients?
So Dr. Liu, this is a question just for you. It's kind of a modified question of what I asked. Do you have a rough timeline when your AI tool could be available to PCPs and NPs in the future? Will there be a separate version for medical specialists and lay people? Which pretty much what I asked you.
Yeah, so those two questions. One is timeline and two is versioning. So timeline-wise, we don't have anything to share at the moment, but maybe in a couple of months, we'll hear a little bit more about sort of potential timelines. As for versioning, the version that is meant for use by quote unquote everyone should be usable by professionals as well as lay persons. However, the version that's meant more for clinician use, which is not what we're focusing on right now, it's more in the research phase. That version, I think it's going to be much more targeted and provide information that's more appropriate for clinicians.
Okay, I think that's our time. We could have gone a little longer, but this is it. Thank you, Dr. Papier, Dr. Thakur, Dr. Borve, Dr. Conover, and Dr. Liu.
Dr. T.
It was a pleasure.
Yeah, I
Thank you, Sherlock.
just want to hand these mistletoes virtually over to Dr. Oakley. Thank you, Amanda, for organizing all this stuff. Man. Awesome.
Okay.
I know I can't send this through DHL because of your COVID regime. Thank you.
Thank you, guys. Thank you.
Thank you very much.
Next is Dr. McCoy.
Thank you, everyone.
Yes,
Who is
I'd
going
like-
to be, you look so different. Anyway, Dr. Karen McCoy is going to start the next session. And thank you very much once again for that lovely presentations. Bye.